Volcanic ash cloaked a fighter's heat plume, unintentionally boosting stealth. In October 2021, Russia's Rostec ran a landmark test. They fed volcanic ash from the Shiveluch volcano in Kamchatka into the gas generator of the PD-14 engine for the MC-21 airliner for 1 full hour. The result? No performance degradation, no damage after disassembly. That is a real, documented event. But it has absolutely nothing to do with the Eurofighter Typhoon or its infrared fingerprint. Now let's address the premise of this video directly. There is no documented evidence anywhere that volcanic ash ever silently muffled the Eurofighter Typhoon's IR signature in 2021. No operational report, no maintenance log, no scientific paper. The entire idea is a speculative construct that mixes real physics with a fictional scenario. So what is the actual physics that might have inspired this myth? Here is the real physics. Jet exhaust contains soot particles. Soot emits infrared radiation very effectively. A patent from 2012, filed by aerospace engineers, explains exactly how to detect volcanic ash in a jet plume. The idea is simple. Monitor the infrared emission at the 2 to 4 micron wavelength. That is a spectral window where water vapor does not block the signal. The patent notes that at cruising altitude, around 30,000 feet, the surrounding atmosphere has a temperature of about -48 degrees Fahrenheit. That is roughly 229 Kelvin. The jet exhaust, by contrast, is around 900 to 100 Kelvin. Using Wien's displacement law, the spectral peak of that hot exhaust is about 3 microns. That is the exact window you monitor. When volcanic ash enters the engine, it gets heated to the same temperature as the exhaust. And because solid particles like ash and soot are much stronger infrared emitters than gases, the presence of ash increases the intensity of the radiation at that 3 micron peak. That is the basis for detection, but the key word is increase, not decrease. Ash raises the signal, it does not muffle it. The patent provides specific calculation examples. It states that a normal concentration of soot in jet exhaust is about 3 times 10 to the -4 grams per cubic meter. If you add ash, the total particulate concentration goes up. A dangerous ash concentration triggers enhanced maintenance procedures, which include more frequent inspection of turbine blades and hot surfaces, not a reduction in infrared detectability. So why might someone think volcanic ash could muffle an IR signature? The physical effect that could theoretically reduce emission is scattering. Ash particles, which are microns in size, can scatter infrared radiation. But here is the problem. The primary effect in the hot plume is absorption and re-emission, which boosts the signal, not scattering out of the beam. Scattering only becomes significant for much larger particles or at very specific viewing angles, not as a broad muffling effect. Now let's look at the 2021 timeline. The Cumbervieja volcano on La Palma began erupting on September 19, 2021. Over the following weeks, its ash plume affected civilian aviation. On October 13, a Ryanair Boeing 737-800, flying from Tenerife to Brussels, encountered volcanic ash shortly after takeoff at 22,000 feet. The crew declared an emergency and returned. The engine was damaged by the abrasive silica particles. That is a documented incident. But notice the problem. That is a civilian airliner, not a Eurofighter Typhoon. And the issue was engine damage, erosion of compressor blades, and clogged turbine cooling holes, not a change in infrared signature. The ash acts like sandpaper on the hardware, not stealth technology. The Typhoon, in 2021, was not flying routine sorties through active ash plumes over La Palma. There is a 2010 incident involving the Eurofighter Typhoon and volcanic ash. In April 2010, the Eyjafjallajökull volcano in Iceland erupted. UK Typhoon engines were temporarily grounded for inspection after ash was found in one engine. But that was a safety precaution, a routine check, not a classified IR signature test. And it happened in 2010, not 2021. The two events are often confused in online discussions. The confusion likely stems from a misreading of the physics. If ash changes the emissivity of a surface, it could theoretically affect the IR signature. Emissivity is a material property, the efficiency with which a surface emits thermal radiation. A coating of silica-rich ash on a hot nozzle could alter its emissivity in the 3 to 5 micron band, which is the primary window for IR seekers. That is a plausible mechanism, but it has never been observed on a Eurofighter in 2021. But there is a catch. For ash to coat a nozzle, it has to first pass through the engine. And at the temperatures inside the combustion chamber, over 900 degrees Celsius, the silica melts and forms a glassy deposit. That deposit is not a thin, uniform stealth coating. It is an uneven, brittle crust that degrades engine performance and requires costly maintenance. And it increases, not decreases, the mass of particulates emitting IR. Let's return to the only documented 2021 volcanic ash test involving a jet engine. The Russian PD-14 gas generator test with Shiveluch ash lasted 1 hour. After disassembly, no undesirable consequences were found. That is impressive engineering, but it tells us nothing about the Eurofighter. The PD-14 is a turbofan engine for a medium-haul airliner. The Typhoon uses 2 Eurojet EJ200 afterburning turbofans, a completely different design with a different thermal cycle. The EJ200 engine produces approximately 60 kN of dry thrust and over 90 kN with afterburner. The operating temperatures and pressures in the afterburner are significantly higher than in a civilian engine. If ash were ingested, the afterburner flame would be the first to react, and the IR signature of that afterburner is orders of magnitude brighter than any civilian engines. Any scattering effect from ash would be dwarfed by the afterburner's thermal emission. So where does that leave us? The available search results, which include Rostec press releases, aviation news reports, and patent filings, contain zero evidence of any Eurofighter IR signature change caused by volcanic ash in 2021. The only real volcanic ash events that year were civilian flight disruptions and a Russian engine test. The thermal ghost scenario is not supported by any document, observation, or reputable analysis. What is real is the physics of IR detection. The patent I referenced describes a monitoring system that uses an infrared sensor to detect the increased radiation from volcanic ash. The system triggers alerts when the IR intensity in the 2 to 4 micron window exceeds a threshold. That threshold is calculated based on the normal soot concentration and the concentration of ash that would require enhanced maintenance, about 2 times 10 to the minus 4 grams per cubic meter in the ambient air. In conclusion, the story of volcanic ash muffling the Eurofighter Typhoon's IR fingerprint in 2021 is a myth. It mixes the real physics of IR emission from particles with a fictional scenario. The real 2021 events were the La Palma eruption disrupting civilian flights, the Russian PD-14 test with Shiveluch ash, and no Typhoon operations involving volcanic ash. That is the boring, factual truth. And in defense analysis, boring is often more valuable than spectacular. When you hear a story about a thermal ghost changing a fighter's signature, ask yourself, where is the data? If the only source is speculation, it's probably not real. And if you are looking for actual defense analysis, always go back to the documented facts, not the cinematic myth.